Section 2.1 is on right triangle trig. So for a right triangle, normally we are going to be naming it triangle ABC. And C is always going to be the right angle. Right triangle trig, like you went over before in previous classes, is where we're going to use their SOHCAHTOA, where we have sine as opposite over hypotenuse, cosine as adjacent over hypotenuse, and tangent is opposite over adjacent. And whenever you're looking for the opposite side, remember it's the one across from the angle you are looking from. So for this one, if we're looking at the side opposite of B, it would be the one across from it. So example 1, they want us to use triangle ABC with C being 90 degrees and side length A being 6 and side length C being 10. They want us to find the 6 trig functions of A. So in order to do that, we first need to find our third side of the triangle. And we can use Pythagorean theorem to do that. And we would get 100 equals 36 plus b squared. Subtract 36 to get 64 equals b squared. So 8 would equal b. Now that we have that, we can go ahead and find our trig functions of angle A. So sine would be 6 over 10, which would simplify to 3/5. Cosine of A would be 8 over 10, which would be 4/5. And tangent of A would be 6 over 8, which simplifies to 3 over 4. And once we have our first 3 trig ratios, we can then find the reciprocal functions. So the cosecant of A would be 5/3. The secant of A would be 5 over 4. And the cotangent of A would equal 4/3. So that is how you can find all 6 of the trig functions when you are given a right triangle. Next, we're going to go over the cofunction theorem. For this one, a trigonometric function of an angle is always equal to the cofunction of the complement of the angle. So 2 cofunctions are sine and cosine, tangent and cotangent, and then secant and cosecant. So what this means in some examples, we are going to fill in the blanks so each expression becomes a true statement. Because sine and cosine are cofunctions, we need these 2 numbers to be complements of each other. So we would have to use 60, sine of 60, and cosine of 30. And if we were to look at that, if we found the sine of 60, that would be the square root of 3 over 2. Then, if we were to find the cosine of 30, you would notice that is also the square root of 3 over 2. So that's what it means to be cofunctions. That if you found the function value of the reciprocals for each of them, they're going to equal the same thing. So that's why they're cofunctions. So for part B, we need to find the complement of y. And we would find that the same way we would find it if we were given a number value. We will take 90 minus y. And the next one, we have secant and cosecant, which are cofunctions. So we would take 90 minus 75, and we would end up with 15 degrees for our answer. So that's how you are going to do cofunctions. This is important to study and know how to fill in these blanks because there will be a few questions like this on quizzes and on the test. All right. And this section will be useful if you're using the TI-84s. You'll want to make sure your calculator is in degrees during this chapter. And this explains how to do that. And when you're given exact answers, I do not recommend using your calculator because if you have like a side length that involves a square root and you use your calculator, you'll end up with a decimal. Excuse me, which is something that you don't want. So be cautious when you use the calculator. Sometimes it's best to just use it to check your answers. This table, if you memorize all these values, it will definitely be helpful to you because these are the most commonly ones that we use. Also, if you do 45 degrees, those would be good values to know for sine, cosine, and tangent as well. If you don't have them memorized, at least knowing your special right triangles so you can find these values will be very useful and it will save you a lot of time in the future. So, for example 3, we are going to use the exact values from the chart above to show the following are true. So we're going to take the cosine of 30 squared. So remember, that means we're going to evaluate what the cosine of 30 is, and then we're going to square it. So in this example, it would be a square root of 3 over 2. Then we're going to do the same thing for sine of 30, which is 1/2, and we're going to square that. And remember, you square both the top and the bottom number. So we would get 3/4 plus 1/4, which equals 4 over 4, and also equals 1. Then we'll do the same thing for cosine of 45 and sine of 45. And that one's not on our table, but if we do the cosine of 45 and sine of 45, we will get the same thing. So it'll be the square root of 2 over 2 squared plus the square root of 2 over 2 squared again, which will be 2 over 4 plus 2 over 4. Showing that this one is also true. Our last example, we are going to let x equals 30, y equal 45, and in each of the expressions, we are going to simplify them as much as possible. When you have a number in front of your function, you are going to first evaluate what that function is, and then you are going to multiply it. So x is 30, so we're going to take 2 times the sine of 30 degrees, which would equal 1/2. So this will be 2 times 1/2, which equals 1. So that's how you evaluate if you have a number in front of the function. Now, if the number is inside where you are multiplying it, you are going to first multiply those two numbers together and then take the sign. So this one, y is equal to 45, so we're going to have 2 times 45. And this will equal the sine of 90 degrees. Because that one is on the axis, we're going to use one of these 4 points again. And remember, these coordinate points help us evaluate sine, cosine, and tangent when it's on one of the axes. And the coordinate points always go cosine and then sine, which would represent our x and our y values. So for this one, we're doing the sine of 90 degrees, which would be over here, and sine is the y coordinate, and that would make this equal to 1. C uses all of the information we used in part A and B and applies it into one problem. So why don't you try that one on your own, and once you have your answer, click play to see if you got it correct. So for this one, we have 4 times the sine of 3 times x, which is 30, minus 90. And if we were to simplify everything in the parentheses, 3 times 30 is 90, and 90 minus 90 is 0 degrees. And we can use the same diagram we drew before, and the sine of 0 is also going to be equal to 0, which would make that our final answer for this problem. So those are all the examples for this section. If you have any questions, let me know, and I will get back to you as soon as